In this module, Module 5, we're going to talk specifically about secure coding for authentication and authorization. There's a lot of code samples in here, and we'll talk about each and every one of them, but many of them are relatively self-explanatory. The idea is that you know how to write secure code to effectively authenticate and authorize users. Our objectives here are first and foremost that you understand the process of authentication and authorization, and we explain how you use it both in web forms, ASP.NET Core, and in MVC. We're going to learn some specific defensive techniques in all three of those areas: web forms, ASP.NET Core, and MVC. First of all, some people use these two terms interchangeably, and that's not quite correct. Authentication is the process of verifying a user's identity. We have some sort of credentials. It could be as simple as a username and password. It could be two-factor authentication, biometrics, whatever you like, but we want to verify this person is who they claim to be. Authorization is giving that particular user specific rights based on their identity. Now, they're obviously closely related. I can't give you authorization until I've done authentication, but they're not the same thing. One is finding out who you are, the other is finding out what you should have access to. There are some attacks that can be executed if you don't have good authentication and authorization. The most obvious one is account hijacking, taking over a legitimate user, pretending to be them. Man-in-the-middle attacks and phishing attacks often are based on poor authentication and authorization. The most obvious, and it's the ultimate goal of all of these attacks, is simply unauthorized access to data. If you don't have sufficient authentication and authorization, then unauthorized people can access your data. And this leads to information being leaked. Every organization has information that they want to keep confidential, and authentication and authorization are the primary weapons in keeping that information confidential. Also, if you have poor authentication and authorization, an attacker might get access at one level of privilege and be able to use privilege escalation to get a higher privilege level. And finally, simply sniffing. If you're not doing this well, someone could sniff out from network traffic usernames, passwords, or other information. Let's start with web forms. Web forms are a great place to start because they're obviously exposed. They're running on the internet. Here we can see a diagram that shows the whole interplay from a client setting at their laptop throughout the entire web application architecture that includes the web server, any enterprise services, and the back-end database server. All of this, you'll notice, is supposed to be done with secure communication. Now, they give you two options, SSL and IPsec. Let me first state that SSL, Secure Sockets Layer, is an older technology. By the late 90s, it was supplanted with TLS, Transport Layer Security, but most books and references still just say SSL. Please understand that we mean TLS. It's unlikely you're using SSL today. You're almost definitely using the successor TLS. In any case, they're mentioning two different types of secure communication here. We have the SSL TLS or IPsec, which would be a VPN. Either of these can be used to ensure that all the communication, including the authentication and authorization, is encrypted. And we see several different authentication methods here and authorization methods. We're going to explore all of these in this lesson. Different levels of authentication. .NET Framework has built into it 3 different levels of authentication depending on the web application security level. There's the ASP.NET authentication, the Enterprise Services authentication, and the SQL Server authentication. Let's begin with ASP.NET authentication. ASP.NET is very flexible. It gives you a lot of alternatives. You can code it or you can delegate the authentication to some other service, an authentication service. We'll see some of that in this lesson. The ASP.NET layer is just below the IIS, Internet Information Services layer, in the web application architecture. So basically what this means is this is the part you have the most direct control over as a programmer. All of your requests are going to still go through that IIS layer before they get past to ASP.NET. Now, what does that mean? Well, put simply, your ASP.NET web application is running on an IIS server. So IIS will do some processing before your web form sees any data. So the IIS layer could do some decisions on denying access without even passing that request to ASP.NET. One of the modes we have available to us in ASP.NET Authentication. Now, some of these are more appropriate for one scenario versus another. That's why they give you so many different options. You can see in the code sample here that there's authentication mode equals, and there's a drop-down box, and you have 5 options: Forms, Passport, None, Windows, and Federated Authentication. Each of these are the appropriate choice for a specific scenario. Starting with Forms authentication. You have a form where the user puts in credentials like username and password, and you have some sort of customized logic which is going to verify if that person is a real user or not. This is a great place to use like stored procedures and parameterized queries that we talked about in the previous module to take that username and password and compare them to a database. Whatever the case, you're going to do your own logic on how to authenticate. It has a lot of flexibility. You could require a password and a CAPTCHA, for example. You could require a password and answer a question if you wanted to. You can make this as sophisticated as you want, or it can be a simple username and password. And certainly ASP.NET includes a login control that has just a username and password. Now here you can see the basic steps for doing ASP.NET Forms authentication. There's 4 steps. You have to enable anonymous access in IIS. Now why is that? Well, we don't want IIS to be doing the authentication for us. So it will just pass through everything to our form, and our form does the authentication. We have to go to the web config file in step 2 and configure the authentication section. And you can see here it's just a few lines of code. We tell it we want to use forms. We tell it we want to protect all of the web application. We tell them the login URL, and we tell it the timeout. Step 3, we configure the authorization section. Are we going to allow certain users? Are we going to deny certain users? Now what's interesting here, and this was done very well, we allow one specific user and then we deny everyone else. This is a case of if you're not authenticated, you're not coming in. And that's the way you should usually do it. Now the last step is the hardest. You actually create your own login page, and that's going to take a request for login data and a response from the server before you can actually authenticate the user and let them in. Passport authentication is a different method. It's centralized and it's from Microsoft. It's a service they provide for authenticating users, and it uses an encrypted cookie. Now we discussed in a previous module things like cookie poisoning. That's why this cookie is encrypted. Basically, it can be used in several situations. If there's a username and password that aren't configured for database or login access, we don't have them in a database. Users are willing to provide some personalized content. The passport from Microsoft has some personal data from them. The site's used in conjunction with other sites that use passport authentication. Now this is a great reason to use passport authentication if you're interacting or your users are interacting with multiple sites and those other sites use this. This allows them to have interchangeable authentication. And basically, you have situations that you've recognized where the user has to sign on, but that these other criteria also exist. And what this means, the way this works is, if a user is already signed in to Passport, then they can be considered to be authenticated and directed to the site. Other users are redirected to the Passport server. So basically, if I've already logged into Passport, then I come to your website, Passport's going to go ahead and authenticate me for you. Now you are offloading the authentication process to the Microsoft Passport server, but as we said, there are scenarios where that's exactly the right idea. Custom authentication. Basically, you've set up the web config to say authentication none. That's not quite true because you're going to roll your own authentication. This is similar to the web forms, only a little more extensive work on your part. And that's the reason you said none on the web configuration authentication methodology, because you're not using any of the preset methods, you're rolling your own essentially. To implement this, you need some classes. So like I said, there's a little extra coding here, but the more coding you do, the more flexibility you have. So this is a method you'll want to use when you need a lot of flexibility in how to do this. The classes are listed here on the screen. They're authentication classes, and they're enumerations or enums for using encryption algorithms, exchange algorithms, hashing algorithms, SSL protocols, and remember that also means TLS. So we have a wide array of different classes you're going to need to implement to do custom authentication. Another method that's not so popular for public websites is the Windows authentication. It's the default mode, and it's based on the user's Windows identity. You rely on IIS itself to authenticate, and if the user's not already authenticated, they're going to see a little Windows login box. Now, as you might guess, that's usually not going to be practical for a public-facing website. But if you have a web application that's being used internally on your internal network, this might be exactly the way to go. There are 5 different Windows authentication methods, so it's not just a Windows authentication or no. You have some choices provided by IIS. Basic authentication. They just give a username and password. That's simple enough. Digest authentication, but instead of sending those usernames and passwords in clear text, they send a hash value, and that gets compared to a stored hash. I would never recommend basic authentication. I don't see why you would ever send username and password in unencrypted format. Integrated Windows authentication. It uses secret key cryptography to encrypt the credentials from the browser to the web server, and then that application is going to use your network authentication, which could be something like Kerberos or NTLM, to provide authentication for the user. Particularly when you're using this in a domain and it's an internal application, integrated Windows authentication is a really good choice. You also have 2 others. Certificate authentication. The client need not only have a username and password, they have to have their own digital certificate. Now, obviously, this is not something you'd use in public websites because most people don't have their own digital certificate. But this prevents someone else from simply guessing my username and password and logging in as me. They would also have to have my digital certificate. I consider this probably the most secure type of Windows authentication, and if you're going to use Windows authentication, whenever possible, use certificate. Now, Anonymous says anyone can access it. We don't really use this as a form of authentication. This is what you set up in IIS when you're going to do your own, either through custom or web forms or something of that nature. Okay, we introduced you to several different types of authentication. How do you pick which one? Well, there's a lot of things you have to consider. First of all, the operating systems of the server and client. Yes, you're running an ASP.NET app, and yes, it's running an IIS. But if you have clients that might be using other operating systems, Windows authentication is out. What about the type of browser are they using? Do you allow any browser, or do you have a set range of browsers they can use? Where are these users at? Are they on your local network? Are they somewhere else? Are they users you already have in your database? Are they not? Are you deploying this across the entire internet or internally on an intranet behind a firewall? What type of application is this? Is this a general purpose application or highly specific for a particular purpose? How sensitive is the data you're being displaying on your website that you want to protect? Do you need this to be scalable? Do you think you might need to scale up to a lot more users later, or no? All of these are some of the factors you take into account when you're choosing authentication. So these application authorization requirements will go into the mix of things you think about when you decide which of these authentication methods you use. As I said at the beginning, it's not the case that one of these is the best. Each of these is the best for a particular scenario. Now here we see a little flow chart which will help you walk through this process. And again, there's not a right or wrong answer. There's a right or wrong answer for a given scenario. So if you walk through this, do users log in or not? Are the users using Windows accounts or not? Is the app running on the internet or not? And we walk our way through step by step, seeing which authentication is the most appropriate for your scenario. We're not going to go through every option on this model. You can read it yourself, but let's look at one in particular. Users do log on. They don't use Windows accounts. They're not in Passport. They're not interactive user logins. And they don't have a secure login. Or excuse me, we do want a secure login. That leads us to a forms authentication using SSL or TLS certificates to encrypt the transmission. Notice I didn't say the user had to have a certificate. I said we use SSL or TLS to encrypt the authentication process. But forms is the appropriate choice here. So just walking through this flowchart will help you decide which one to use. What about enterprise services authentication? We mentioned this before. This uses what's called a remote procedure call, which basically allows one program to call something running on a different program or possibly even on a different machine. It uses the Security Service Provider Interface, or SSPI. That's an API built into the operating system. And we assume a Windows operating system here. Because it's using the Windows built-in security, it's going to use either Kerberos or NTLM authentication to authenticate clients. This service component is then included in the library application, and these applications are included in the clients. So this way we can recognize client identity and authenticate them. We also include the service component in the server-side application, and it runs in a different process on the server with individual identity. And you can see a diagram here showing how those different processes are handled. So if you're going to use enterprise services authentication, these remote procedure calls will authenticate at these chosen levels. Default, that's pretty obvious. None, no authentication, not recommended. Connect, as soon as a connection is established, the client must be authenticated. Call, if you're going to make a remote procedure call, we authenticate again. Now, think about the difference between these two. Connect, I have connected, and now I'm authenticated. I might, after that connection, make 2, 3, 4, 5, 6, however many remote procedure calls. Each of those are not individually authenticated. The call method, every remote procedure call is authenticated again. A little slower, drastically more secure. Packet, it authenticates you and then verifies all call data, whether the data gets received or not. If it gets sent, it gets validated. Packet integrity, we make sure that the packet data is not modified during transmission. And packet privacy, we make sure it's not compromised, that it's encrypted. So integrity will use hashes or message authentication codes. Privacy will use encryption. SQL Server authentication. Okay, at some point, things need to talk to a database. The user is authenticated to the actual SQL Server database with the help of the Windows authentication, either NTLM or Kerberos again, or through the built-in database SQL authentication. So there's two different authentication types in SQL Server if you're not familiar. They're mixed mode and Windows. Windows authentication just uses your Windows network credentials. It's really appropriate in a domain environment. Mixed mode can use either the Windows authentication or SQL's own username and password. Okay, we've authenticated the person. We know they are who they say they are. What about authorization? We said those were two different processes. How do we handle authorization? Well, you have different levels of authorization provided in .NET, and they're very similar to the ones we talked about before. We have ASP.NET authorization, Enterprise Services authorization, and SQL Server authorization. With ASP.NET, we have a few options here. We can do URL authorization, file authorization, code-based authorization, or .NET roles. We're going to look at each of those. URL authorization. We allow or deny access to a particular directory by using a username or role, and we specify a list of users or roles that we allow or deny in the web config. So, here we have a web config file, and we've chosen to allow the users John and admins, and denied users Sean or anyone else we don't recognize. That's pretty straightforward. File authorization. We check the access rights of the user in which the ASP.NET application is running for NTFS file permissions. So this gets very closely related to your basic Windows permissions. When a user requests a particular file, for example, they read, that user account is checked against permissions on that file. The ASP.NET engine, by default, is using the ASP.NET account. And impersonation is false by default in web config. In other words, it's going to run as ASP.NET regardless of what user you are. If you want to use file authorization, you'll need to set impersonation to true. Now, you should think about this for just a moment. File authorization is only going to work if you're doing Windows authentication, because we're tying a Windows account to NTFS file and folder permissions. So if we don't have a Windows account, we can't do that. I said impersonation. What does that mean? It sounds negative. It sounds like an attack, but it's not really. We know that you're logging in through a web application, and we know that ASP.NET is running as its own service, but we would like it to impersonate whatever user you logged in so that it has the permissions of whatever user you logged in as. That's all we mean by impersonation. We have a few options for impersonation. Of course, by default, it's disabled, and unless you're going to do this process we just talked about, it should stay that way. Enabled, ASP.NET impersonates the authentication token from IIS. However the user authenticated through IIS with Windows authentication, it's going to impersonate them. You can also have impersonation enabled for a specific identity. In other words, ASP.NET will only use impersonation for specific logged-in users. Other users, it won't use impersonation. Delegation. If you're doing impersonation, you have this option to allow ASP.NET to access the resources only on the web server where it's running. What if you need to access resources on another server? Well, delegation is a more powerful version of impersonation, and it lets .NET access resources located on a remote server. Now, I think you can already see that this is a very powerful tool, but needs to be implemented carefully because of the fact that you're allowing access to resources on a remote server. Now, delegation is only going to be enabled when ASP.NET can authenticate against a remote server with the client's credentials. In other words, can't use delegation unless the user who authenticated is also able to authenticate on the remote server. Obviously, any sort of access to additional servers does leave open the possibility of more sophisticated attacks, and you should be aware of that. Code-based authorization. You want to write code that does the authorization yourself. Now, just like code-based or customized authentication, code-based authorization is the most flexible. You control everything, but it's also the most work for the programmer because, again, you control everything. There are three ways of doing this: explicit, declarative, and imperative. Authorization using ASP.NET roles. An ASP.NET role is used to control access to resources. The application itself has access to some resources, and it looks at users as a single unit and assigns roles to them. These roles are used to manage access to any resources that group is given access to, or to, of course, deny access to items the group has been denied to. You can restrict pages, you can limit access to resources, all sorts of things. And you can see here that in web config, we simply have role manager enabled to true, and cache roles and cookie true. So the cookie will store your role. We see a particular path, and we allow the roles of members to access members' pages, and we deny access to everyone else. Now, this is an important topic that I don't see used often enough by .NET programmers. You can get really granular in your .NET application. Not only do I allow someone access to my application, but I only allow them to access certain pages. Other pages they can't get to. That's a great way to enforce that concept we talked about way back at the beginning of this course, least privileges. They only have access to things required to do their job and nothing more. What about enterprise services authorization? We mentioned that. Authorization at this level is done through enterprise services. The enterprise services uses its own remote procedure call methods like COM+ and some other similar methods, and these roles are contained with some Windows group, your basic network domain group. And this catalog is used to define role membership. It's administered by a component services tool. So let's say a user tries to call a method on some component. The authentication process starts taking over, and it looks to see whether or not the membership of that particular role allows access to that application. Assuming they are authenticated, the enterprise services interception layer will look and decide what they're able to do. Are they able to call a method, retrieve data, send data, those sorts of things. With SQL Server Authorization, we have a couple of ways to do this, and it's very finely grained, able to get a very granular control over this process. You give role-based membership to an individual based on a Windows user group or a SQL group. You can have user-defined database roles, which this is a group of users who may have a set of privileges based on their Windows group or based on something you've set up in SQL Server. You can give permissions to particular applications, permissions to stored procedures, or of course deny those permissions. And there are of course built-in database roles in SQL Server that you may want to use, such as the data reader and data writer. If you put someone in the data reader role, then that's all they can do is read data, they can't write it. Authentication and authorization within the .NET Core. Let's take a look at that. Authentication can be implemented in the core using basically two processes: .NET Core Identity and Token Authentication. The core identity allows them to log in and log out, manage passwords, register, has lockout policies, can support two-factor authentication, and even third-party logins. The token authentication, it's secure and scalable, great for mobile apps, great for single-page applications because we're depending on essentially a token. So, we use this ASP.NET Core.Identity namespace to maintain access control, and it has a specific type of middleware called OWIN, O-W-I-N, that it works with, and it's what's called a claims-based identity. So you're basically logging in and claiming that you have access to certain resources, and that gets validated or rejected. And you can see the identity managers used here, and you can see the various identity stores that are part of this process displayed here on the screen. So what are your options? There's no authentication. You get to things with no authentication at all. That's not usually recommended. There's individual user accounts. Each user has their own account. What they call work and school accounts, which authenticates users with Active Directory or Office 365 or something of that nature. And of course the Windows authentication. There's also a template now called social authentication, where you take their Google, Facebook, Twitter, or Microsoft account and use that to authenticate them. That's getting real popular because people don't like to log in to lots of different things. However, I would caution you, if this is very, very secure data, you probably don't want to use social authentication. The number of breaches of those third-party social media websites is phenomenal, and the chance of someone breaching someone's, for example, Facebook or Twitter account and then using that to authenticate to your service is fairly high. So here we're looking at those templates and specifically how you use them. So basically we're showing you how to find this inside of Visual Studio. Now do be aware that from time to time a new version of Visual Studio will come out and things get messed around a little bit, so don't be too shocked if you have to look a little bit. But for now, you can go to File, New, Project, .NET Core, ASP.NET Core Web Applications, and you'll see the screens you have here. Here we're showing you picking the work or school accounts, and we're going to use cloud for a single organization, or we're going to use Windows authentication. We're showing you both the options here. What about external providers? Again, there are a lot of external processes out there, such as OpenID and OAuth, that we'll be seeing throughout this course. You can tie those into your application. Those are commonly used. The OAuth is open source. A lot of people like to use it. And here we see we have some namespaces for that. ASP.NET.Security.OAuth providers, or Microsoft.ASP.NET Core.Authentication.OpenID Connect. These are both providers that you can integrate into your system so that you can use those, either OAuth or OpenID Connect. You can also see through the OWIN middleware, we have Facebook, Google, Microsoft, OAuth, Twitter, and just Owen's Own Security. Here are a few of the open source authentication providers that are also available to you in .NET. You see ASOS, Identity Server 4, OpenIDDict, and PWDless or passwordless. These are all different methods you can use, and you can integrate them into your .NET application to use those open source authentication providers. Lots of people like to use these because they can use the same authentication for multiple different applications or websites. How do you enable this ASP.NET Core identity? It needs to be included in the project, and it's enabled using dependency injection. And you can see here on the screen where we're saying app use authentication. And we see the dependencies that must be available. So if you get an error message, check to make sure these particular namespaces are available in your project. If you didn't include them all, that may be the source of your problem. Core token-based authentication. We mentioned that before. How does it work? First of all, tokens are stateless. It has information about the user. It's not stored on the server. We don't know the particular session. We just know this user. It's used to authenticate for multiple applications. It's a single sign-on thing. So if I have a token I've authenticated once, I can present that token to a range of applications and get access to all of them without having to re-authenticate. User requests, first of all, they're authenticated with a password and username, and then the application provides a digitally signed token to the client, and the client stores that token, and from that point on will send it with each of its requests so that it doesn't have to re-authenticate. And you can see a diagram here showing you the actual HTTP messages being used in this process. Here we're seeing a specific token, the JSON Web Token, abbreviated JWT, and you can actually see a sample token. It's obviously encrypted, so that sample token doesn't show you a great deal, but we can see here that this is supported from .NET Core 2.0, so we can incorporate JSON Web Tokens. The structure is pretty straightforward, and again, a lot of this is handled for you because it's included in .NET Core. And here we see a few simple steps happening in your startup.cs file and in your appsettings.json to enable the JSON Web Token authentication process. Not a lot of changes to the configuration, a few single lines you can see here, and now you're using JSON Web Token authentication. Now, creating a token does take a few lines of code. Incorporating the service is one thing, but creating the actual token is a little different. Here we actually have an entire function called generate JWT token. And you can see how it's fairly straightforward to generate a token. In this case, we're using their names, a globally unique ID, we're using the username, we're using encryption to encrypt all of this, and providing the user with a token that they can now use on other applications we've created. Now, how do we access those tokens? jQuery is the preferred method, and you can see right here we have the code in a forgot password HTML file that will go out and get that token. And we had to add just a little bit to our startup CS to allow it to use these static files because the token is itself a static file. What about Identity Server 4? Well, this is an OpenID Connect and OAuth 2.0 framework. So it uses both of those methods. It has centralized login. Again, you log into one place and you now have access to multiple different resources. So it's single sign-on. It also uses tokens for accessing APIs. And it also lets you get to external identity providers like Google and Facebook because they support this as well. But it is customizable. So here we can see a simple 5-step process that will allow you to implement ASP.NET Identity with Identity Server. We notice that the final step on this screen is to include the package Identity Server 4 ASP.NET Identity. That gets installed automatically when you install the identity package. Here we're seeing an actual implementation of that installation. You can see browsing inside Visual Studio to locate the appropriate package and make sure it's installed. Here we see simple configuration changes to config.cs and startup.cs to support this particular methodology of authentication. There isn't a whole lot of code to it. Most of it is handled within the package that you're including. Now we simply go to Services and we configure the identity server in our services. That's done in startup.cs. That's where most of your work is going to happen in implementing this particular authentication methodology. Here in Step 8, we want to create a database of all these different users that are included in this process. But you can see that this is done right here at the command line. It's a few simple commands and the rest is done for you. All right, what about configuring Windows authentication? You want your Visual Studio application to enable Windows authentication. Well, again, it's a step-by-step process done right there in Visual Studio where you change the authentication method and you simply select Enable Windows Authentication. That's it. And you can see that right here on the screen. Now, if this is using Windows and an anonymous authentication, you're going to look in the Launch Settings JSON file, which is shown here, and you can see where those are both checked. You already checked those in the configuration we just showed you on the last screen, but here you can see where that value is set. You could, of course, have gone here and manually set it. I usually don't. I just do it through the screen inside Visual Studio. You also need to enable Windows authentication with IIS, with ASP.NET applications, and here we select the authentication. And you can see under IIS, I picked a particular site, a web application. I chose the authentication mode, and I chose Windows authentication. And you can see the options used there, whether I've enabled or disabled them. You can also enable Windows authentication to use HTTP SYS or Web Listener. This is a process that's not nearly as common as the other ones we've seen, but you configure the app's web host to use HTTP SYS with Windows authentication. And if you wish to do that, you can see that right here in program.cs, right in the very code shown on the screen here. Now, Windows authentication has a couple of attributes: authorizing and allow anonymous. Authorize will grant access to a resource, assuming the person is authorized, their Windows username and password checks out, and allow anonymous will allow access to everyone. Obviously, you normally don't want to allow anonymous. You may allow anonymous to specific sections, but not to all of your web application. When you enable Windows authentication and disable anonymous access, the authorize and allow anonymous attributes can no longer be used because you've just made a selection. Authorize and allow anonymous can be used when both Windows authentication and Windows access are enabled. In other words, if you chose to disable anonymous access, these other attributes we just discussed are no longer relevant because you're not allowing anonymous access. That's pretty straightforward. Here we can see inside the ASP.NET Core, we can see right in our startup.cs, we're adding authentication with IIS defaults. So we're telling the application to use whatever IIS is using, which is what we were just configuring on the last screens. Impersonation. ASP.NET Core doesn't support an impersonation feature by default. We've seen some ways to do some impersonation. All requests are executed with the application identity using your application pool or process identity. You can use the Windows identity, run impersonated, to execute a specific request on behalf of a user. That allows you to execute a single action in that context and then close out the context. ASP.NET Core Authorization. This is another authorization mechanism we've discussed. And this happens just before a method executes, before you do something. It's part of the MVC pipeline, and it's in the MVC middleware. Basically, you can see here an authorization namespace, the Microsoft.asp.NET Core authorization, and it has either authorize or allow anonymous, which we've discussed before. You can see a nice little flow chart shown here telling you exactly what happens in this process. Now, a lot of these processes we're discussing and these flow charts we're showing are actually transparent to you. They're handled by various .NET components that we've been discussing, but it's probably interesting for you to at least know what's happening behind the scenes. Here we can see some code samples. In the first one, we're allowing access to non-authenticated users, and in the second one, we're applying authorization to a specific controller. So we see that you have little options here on how you want to handle this. Now, this whole idea of allowing non-authenticated users, well, if you think about it, e-commerce sites tend to allow you to navigate and shop, and you don't have to do any sort of authentication until you actually make a purchase. You don't make people authenticate before they can even look through your goods for sale or your services for sale. That's a classic example of where you might allow anonymous access to non-authenticated users. Here we have the Role Manager, which is part of the ASP.NET Core Identity Service, and role-based authorization checks are declarative. In other words, we're saying we want to authorize the admin user in the administrators group. We're declaring something, and that, of course, will be checked to make sure we have that authorization and we can prove we are that person. To implement policy-based role checks, you register a policy at startup. So we go back to the startup.cs. As I told you earlier, that's where a lot of your code's going to happen if you're doing authorization and authentication. And you can see here we chose an option to add a policy, administrative rights, and the policy requires the role of admin. That's pretty straightforward. Claim-based authorization. Every identity is assigned one or multiple claims. Claims are basically saying, I'm authorized to access this resource. I'm making a claim. So claim-based authorization will grant access to those resources based on the value of the claim. So we're going to check to see if your claim is valid. I have claimed that I am user J. Smith, and I have access to this resource. I've made a claim. Well, actually, the code has made the claim. The system will check that claim, validate, am I J. Smith? Does J. Smith have access to this resource? And if so, grant me that access. Here we give a list of allowed claims when we create the policy. What do we allow to happen with this policy? So we're setting a policy in our startup.cs, again, where all the good work happens. The policy's employee only. So we're going to require a claim of employee ID. If you don't have an employee ID, well, we're not going to allow you to access anything that has the policy of employee only. Custom policy-based authorization. As you already know, anything custom is far more flexible, but far more work for the programmer. Here you have complex authorization that go beyond role or claims-based, and you have one or more requirements, and each of those can have one or more handlers. And you can see here a chart showing you some of those requirements and the handlers. So to create this, we need to first create a requirement, then create a policy, then create authorization handlers. Then each requirement defined in the policy must be satisfied. Now make sure you understand that. If you have 3 different requirements in your custom policy, it's not the case that one of the 3 must be satisfied. Rather, it's the case that all 3 of them must be satisfied. So make sure you're very careful in the requirements you select. For a requirement to be satisfied, any of the defined handlers should be satisfied. So whereas the requirements are all or nothing, the handlers for the requirement, any one of them works, then the requirement is satisfied. This flow chart kind of clarifies what we were just talking about. We start from, is the policy satisfied? Well, we look at the requirements. Now notice these are and statements. Requirement 1, requirement 2, requirement 3, all have to be satisfied. But to satisfy a requirement, and the chart shows you requirement 2, any of the handlers, handler 2A or 2B all the way out to handler M, if any of those are satisfied, then the requirement is satisfied. Resource-based authorization. Another way you can authorize access to various resources, web pages, files, whatever. In this case, resource-based authorization is imperative authorization. We call to authorize function within the code. You can use role-based authorization as a service. Actually, there is an authorization service built into .NET. The service is registered in the service collection and available via some dependency injection for controllers. This goes back to our MVC view. Now here we're looking at some code samples of this. One of the things I said you'd like about this lesson and the previous one is we give you code samples throughout, so you don't have to speculate on what we mean. You can see exactly how to do it. Now in this case, we're looking in the employee controller.cs, and we're using here resource-based authorization to provide employees access to a specific resource. View-based authorization. We want to display, hide, or modify content based on the current user. Now this is one I really like because in any sort of application, particularly web applications, users may have access to some resources and not others. I'd prefer not to even let them see things they shouldn't look at. Instead of disabling something or letting them see a grayed out screen, I just don't let them see it. View-based authorization lets you do that. It's done within MVC views and can be accessed again via dependency injection. So basically, you include authorization service in every view and include the inject directive into the view imports CS/HTML file for that views directory. You don't implement views authorization as the sole authorization method because all it's doing is hiding the UI element. Put another way, this is security through obscurity, and in and of itself, as we said in Module 1 and Module 0, that's not good enough. But it does provide some guidance to the user if they can't even see something. You include authorization code in the controller with the view-based authorization. Now let's take a look at authentication and authorization in the MVC. Basically what happens here is the server redirects users to some login page anytime they request access to something. The authentication filter will validate their credentials that was sent with that login request. If the credentials are valid, they're logged in and redirected to whatever it is they're trying to view. Now you can see here some authentication options, another screenshot straight from Visual Studio. No authentication, individual user accounts, work and school accounts, or Windows-based authentication. The MVC authentication filter is used to authenticate the user, as the name suggests, and it's the first filter executed for any request. It was first introduced in MVC 5 and continues today. Before that time, the authorization filter was used for both authentication and authorization. Now we have a separate filter. Now you can see here step-by-step instructions if you'd like to create a custom authentication filter. It's not particularly difficult. The instructions are laid out for you right here on the screen. Feel free to experiment with that a little bit. Now here we're going to show you actual code in an on authentication method. So you can see right here in the code, if we're trying to authenticate someone, we're using the filter context, we're using the result, and we're choosing either to give them an error message or to give them access to that particular view. What about single sign-on? Single sign-on is popular, and I realize some security professionals are skeptical of it, with the thought being, if I'm able to break into one account, I now have access to all of your accounts. That's true. But the reality is, if an end user has to keep 4, 5, 6, 7 logins, what they usually do is write them down. And I'm sure you can relate to this. Lots of users write them down on sticky notes and put them right on the monitor of their computer. Well, that provides zero security. If they instead have a single login that gives them the access to multiple resources, they can memorize that one login. They can manage that one username and password. So in those cases, single sign-on is preferred. Here, to use single sign-on, you implement it by sharing the form authentication cookies across web applications. And we use a machine-level web config to generate the validation key and decryption key for that cookie. And you can see that code actually shown right here on the screen. What about third-party identity providers like OpenID? They have a login page that's implementing OpenID. The browser redirects the user to the OpenID provider, like Google or Facebook. They log in using their username and password, and that permits the website to use this identity. They're then sent back to your website. Basically, you're piggybacking off someone else's authentication method. Page access control. Now here we're getting granular with our authorization. We're going to give you access to a particular page action, a specific activity on a page. And you can see right here we have homecontrollers.cs and we have authorized users John. So only John should get to see this. Then we have administratorcontroller.cs and we have authorized roles administrator. Only the administrator gets to see this. Using some defensive techniques in your web forms. First of all, these authentication tickets must be maintained with the setting Protection All in machine config, not web config. This allows for integrity and encryption of all authentication tickets. If that attribute is set to none, then that authentication ticket is set in clear, and there's all kinds of attacks that are now open. So what I'm telling you is you always want to go to your machine.config and have protection set to all for any web form applications. Ensure this is set to all in both machine.config and web.config, and you can see that right there on the screen. Now, the machine.config is probably the more important, but do it in both places. If you only do it in web.config, you're going to have serious problems. Use strong hashing algorithms to validate data. If you're paying attention to security at all, you've seen some attacks on various common hashing algorithms. What's being suggested now are the stronger versions of SHA-2, such as SHA-2 256, 384, or 512, and even better using a hash message authentication code, or HMAC with SHA, as opposed to simply a hash. You can see that done here in the web config. On the left side, we have an old MD5. On the right side, we have HMAC SHA-512, vastly preferred. Now, it's not widely implemented yet, but in 2012, the National Institute of Standards did approve SHA-3. Use strong encryption. You have good encryption, powerful encryption available to you right there in .NET. Why would you ever use an old, outdated encryption method? On the left-hand side here, we can see DES. Now, DES was first publicly described in 1976, and at that time it was a revolutionary algorithm and was fantastic, but that was in 1976. Today, if you're using DES, there's no other way to put this except you're wrong. No nice way to say that. We have advanced encryption standard. Now, you don't have to be an expert in cryptography to understand this. Let me just explain to you that the National Institute of Standards in the United States says AES is sufficient to encrypt top-secret classified documents. Well, if it's good enough for that, it's probably good enough for your application. So a simple thing of moving encryption and decryption from DES to AES made for a much stronger authentication process. Secure form authentication. Okay, you are encrypting these tokens. You're encrypting your authentication information. But what about the communication between the login screen and whatever backend service? Require SSL means it will use, again, SSL or TLS, most likely TLS, to encrypt that whole communication. Put another way, your authentication token is encrypted and the communication that transmits that token is also encrypted. So for an attacker to get at that data is very difficult. There's no reason to ever not require SSL set to true for your authentication, for forms authentication. Secure form authentication credentials. Notice here we have a hash algorithm. Your password should always be sent and stored as a hash. So here we have vulnerable code where we just have a password. On the right-hand side, though, we have secure code where the password is stored as a hash. Makes it much more difficult to subvert the password process. Prevent session hijacking using cookieless authentication. Now, if you're going to use cookies, we've seen processes in this lesson that use them. That's okay. Make sure they're encrypted. And encrypted cookies are extremely unlikely to be compromised, and I mean extremely. However, no cookies absolutely can't be compromised. So here we're looking at using vulnerable code that has a forms cookieless using the URI. On the right-hand side, we're using cookies, but it's an encrypted cookie. In other words, we're using an authentication method that does not store things in the URI. Using cookies instead of a URL to store tokens is usually a better idea even if we want to avoid cookie poisoning. Just make sure you encrypt the cookie. Avoid form authentication cookie persistence. Now this is another thing. Your cookie shouldn't stay very long. Notice here that we don't even allow the Remember Me option. I've seen lots of websites, and I'm a little disturbed when I see financial websites that do this. Remember Me. That's convenient, easy to get back into, but that means somewhere on my machine or somewhere is stored my login information, and if someone gets my laptop, they get into my account. So we're just going to take that out. We're not going to allow that, and that means whatever cookie is stored goes away as soon as the session is over. That's always the secure way to do things. Avoid form authentication cookie persistence while using the redirect from login page. Here what we're looking at is code that allows someone to redirect from login, and we're saying, no, we're not going to allow that to happen. If you redirect, you get authenticated again. You can't just jump off of this page. Set authorization cookie method. Here's another way. Now notice we're talking a lot about how to secure these cookies, because although there are cookieless methods, cookieless requires you to put things in a URL, and we'd rather have them in a cookie. Form authentication cookies can be prevented from persisting by using set authorization cookie method. And you can see here when we set it to true, we have an authorization cookie that's going to be saved. If we set it to false, that authorization cookie does not get saved after the session. It's over, it's gone. Using the get redirect URL method in forms authentication. You can see here again we're showing vulnerable code versus secure code. In the vulnerable code, we allow a redirect URL. In the secure code, we don't. What we're essentially saying is you can't redirect around and save the cookie. Using form authentication ticket constructor. Form authentication cookies can also be prevented from persisting by passing false to this constructor. And you see the code right there. Vulnerable code will be true, secure code will be false. And again, we're looking at lots of methods, and each of these accomplish pretty much the same goal. We don't want that cookie to be persisted after our session is over. And here we see the secure version. We just changed true to false. Now, one thing I hope you're seeing in all of these screenshots and code samples is stopping cookie persistence isn't very hard. There's lots of simple things you can do in your code, changing a line here, a line there, and these should become standard practices that you do in all of your web applications. Secure your passwords. First of all, we're going to require a minimum password length. Now, it's beyond the scope of this course to talk about password cracking in any detail, but if you're curious, you might do a web search on rainbow tables. Those are also covered extensively in the Certified Ethical Hacker course. Rainbow tables are a common way to try to get at passwords. However, rainbow tables get really huge really fast, so minimum password lengths that are sufficiently long enough can prevent rainbow tables from being effective. So here you have on the left-hand side minimum password length of 7. I personally have rainbow tables that will crack that. On the right-hand side, you have minimum required password length of 14. I don't know of very many that can do that. And if you take it out to 18 or 20, I don't know of any that can do that. Now, as a side note, a little extra on this course, long passwords are hard to remember. So you might suggest to users to use passphrases, preferably passphrases that are not obvious to them. If you're a big soccer fan, don't have your passphrase be your favorite team. But you could pick a random thing like oak trees are beautiful. That makes a really long password. I think that's going to be over 25 characters right there. No rainbow table can crack it, and anyone can remember it. And then you could add in some complexity, changing E's to 3's, I's to exclamation mark, that kind of thing. Minimum required non-alphanumeric characters. You might, now this goes back to complexity, we're telling the user you got to put in some other stuff. Put in a exclamation mark. Put in something other than numbers and letters. That makes the password again stronger. You combine this with minimum password length, You've got a really, really good password. Password strength regular expression. Here we again see the vulnerable code and the secure code. The secure code is actually looking at the various things we would like to see. We would like to see some complexity. We want to see numbers and letters and symbols. And this will check for all of those and make sure they're there. And if they're not there, you can't use that password. This is such a simple thing, but I've actually encountered real-world places where this is not implemented. Failed login attempts. We have all typed in our password and typed it in wrong, and that doesn't mean an attack. That means you're a human being. In fact, just this morning I was logging into a website, and my second attempt worked. My first one was wrong. It's no big deal. But how many attempts are you going to give them? The more you give them, the more chances someone has to guess. And unfortunately, many people use similar passwords. You might be a fan of a sports team, and your password at one place is one member of that team, and your password at another place is another member, and another place it's the year they won some national or international competition. Well, if I find one of your passwords, I might guess the others. And if you give me 10 or 15 guesses, good chance I'm going to guess it right. 3 is the norm. You may have situations where you want to make it 4 or 5, but some sort of limit. After X number of failures, I'm sorry, you're not coming in. Your account is locked out. You need to talk to an administrator. Also notice, in addition to the lockouts, we have password attempt window. Basically, how long before you can try this again? I don't want that to be short. You tried 3, you got locked out. Well, in 10 minutes you can try 3 again. That doesn't really help me. Absolute URLs for navigation. Now, we're not so much into authentication now. We're just talking about a secure application. Here we have vulnerable code where we redirect to just login ASPX. Well, that allows people to manipulate that. Instead, we have secure code where we redirect to a specific path. Now, the reason people don't do that is they keep changing their website and they don't want to have to change all the paths. I know it's a little extra work, but using absolute paths is always more secure than relative. There are 2 different methods to transfer from one page to the other. Server.transfer and response.redirect are the common ones. Each one has its own advantages and disadvantages. If you look here on this example code, we're seeing a server.transfer. This is not good for secure pages because it just moves you right on over without actually doing any checking. Redirecting has the entire process of moving you to a whole other location, which may include reinstigating authentication measures. Create a separate folder for those secure pages. Put them in a different location and make them more secure. Even a banking website has a landing page that doesn't need to be secured. On the other hand, the individual account pages need to be very secured. Let's make sure we have a specific folder within our root folder for all the secure things, and we can add additional security to that folder. Here we can see we have a separate folder specifically for secure pages. We have a path to it, and this is done in the web config file. Validating passwords when you create a user. There is a Create User Wizard control that will allow users to create an account, commonly used when someone wants to register. We want to make sure that when they first create the account that they use good passwords. And you can see here there's code using regular expressions that will force them to use a good password. ASP.NET Core defensive techniques. Few simple things you can do here to help defensively code your program. Here we're looking in the startup.cs file to set some identity options. So we're going to require a digit. We're going to require a minimum password length. Now, by the way, these values are being displayed just as examples. I certainly would not recommend minimum password length of 6. I would say 14 or longer. Require non-alphanumeric, require uppercase and lowercase, require at least one unique character, those sorts of things. These are settings you put so that when they're setting up their new identity, we ensure that it has good passwords. Here we see that continue, the same properties we just set, only now they're being shown in code. User lockout, you can see that here, and you have some options here. Not just how many attempts, but how long are they locked out. Now in this case, again, these are just exemplary. A 5-minute lockout is probably not going to be sufficient. Signing in. Do we need to confirm their email ID to sign in? In some situations you'll want that, in others you won't. Do we need to confirm a mobile number, like sending a text and verifying that's them to log in? Banks do these sorts of things frequently. User validation settings. Do we want to validate that this is a unique email, that the username only has allowed characters? Normally you would want to do this. Now we're showing here you can have unique email set to false. I recommend it be set to true. A user cookie has to expire after a specified time by default. Now, we looked at a lot of methods to prevent cookie persistence, and those were for authentication cookies. But I'm saying all of the application cookies, whether they were authentication or not, should expire after some time. Now that time is up to you. In this case, it's set for 14 days. I probably would make it much less, maybe 1 day, but it's your choice. Just make sure that they are indeed expiring. And here we see those settings being shown in code. Now in this case, the time span is 60 minutes. I like that a lot better. Those cookies are going away after 60 minutes no matter what. Enforcing SSL, we've talked about before. Here you can see in the code where we're configuring it globally. It has to be used throughout the application, not just with authentication, but the whole darn thing is going to use HTTPS. HTTP strict transport security. Now that's a newer one you might not be as familiar with. It's meant to try to prevent man-in-the-middle attacks. It includes a strict transport security header which ensures the browser always uses HTTPS anytime it requests any resources from that domain. So if you put this in the preload list of the browser, and you can see an example here, it will always be required. Defensive techniques in the MVC. Allow requests every X number of seconds. What does this mean? We're preventing a brute force attack. In other words, you can only make X number of attacks in X number of seconds. Requests every 2 seconds. 4 requests every 5 seconds. Those are normal traffic. I'm not going to allow you to make 5,000 requests in 2 seconds. That's not normal traffic. That's either a brute force attack or denial of service. So simply setting this, and you can see right there in the account controller, we simply allow X requests every X seconds, and we set that to 3 requests every 120 seconds. That's it. No more. Custom security filters. These are used to restrict IP addresses and do similar things. We can filter individual actions. We can filter globally. Here we see a code example. We have an authorization filter, and we're setting up a security filter in our config file so that we only allow certain things to come in. You might filter out certain users, certain IP addresses, whatever you like to filter. It is custom, so it's whatever you want to filter. Third-party libraries. You're going to have to use third-party libraries at some point. There's no way to avoid it. You have to do it securely. And here we're looking at a specific example where we have is called a Fluent Security Library. This is something being used for an example here. We're including it on this screen. Now, since we did include it, we want to do control level security to ensure that that library, all the controls we get from it, are actually securely used, because there may be things we don't know. Here we can see that going a little further with security filters being applied to specific controls. You can see the code samples here, easy to implement in your own code. Account lockout, we've talked about before. This needs to happen throughout your application. Anytime you have someone logging in and they make a certain number of unsuccessful attempts, they must be locked out. And here we see the vulnerable code and the more secure code with a much lower lockout threshold. Forcing HTTPS by requiring the HTTPS protocol. Here we put it in our global ASAX CS file so that throughout our application they're going to have to use HTTPS, encrypting all traffic. Allow anonymous action filter. You may have situations where you have to allow anonymous. We talked about e-commerce sites. That's very common. There is an anonymous action filter first introduced in MVC4. And here we see the code where we're implementing authorize attribute globally. Now in this module, we've talked about a lot of different things. And it may seem like some of the items contradicted others. That's because different authorization and authentication methods are appropriate for different scenarios. You won't always be able to do maximum security because that conflicts with ease of use. What we hope you have at the end of this module is a whole suite of techniques you can now implement, and that you will go out and implement the most secure technique possible for your scenario.